Okay, this little session on proof, particularly proof by contradiction, is what they're talking about. But we set up a starting point, and it's handy to be able to write algebraic expressions for these common things. Odd numbers, even numbers, rational numbers. Basically, it's quite important that they're done in terms of real numbers. So every variable we're going to use here must belong to, natural numbers, belongs to a natural number. It's a lot easier to process things on natural numbers than it is on irrational numbers. Rational numbers can actually be expressed in terms of two natural numbers, is the point. So the first one, an odd number can be represented as any number, 2 times any number but plus 1. The even number is just 2 times any number, so k belongs to our natural numbers, and a rational number can be written as p over q. So p and q must both be the smallest whole numbers that are possible. Okay. So from these sorts of experiments we can actually prove that the effect of even plus an even, which we should know is even, by using our algebra for an even number. So the first even number we're going to call 2k. The second even number we're going to call 2l. And if we factorise this, we get 2k plus l, which is the form of 2 times some number I don't know, which is the form of an even number. Okay, so that's the argument we can use there. Even times an odd should be even. So let's see what happens when we do that. Again, use 2 different variables. So an even number is 2k, an odd number is 2l plus 1. And when I multiply it through, I get 2k is 4kl, and I plus 2k. And again, I can factorise out a 2 to give me 2kl plus k. And all of this is integer, so therefore this is an integer, so this is in the form of 2n, so it's an even number. Okay, so that's provable that they are even. What happens with an odd times an odd? Well, we take our two expressions, 2k plus 1 and 2l plus 1, and when we multiply them we get 4kl even plus 2kl plus 2k plus 2l, and then we got 1 times 1 on the end, plus 1. And similar to above, this all factorises into a 2n, but we've now got a 2n plus 1, and 2n plus 1 is odd. It's the form of an odd number. Okay, so they are proofs that we can do to give us our nice straightforward statements. Now, this is the crux, is that they actually talk about doing proof by contradiction. Now, contra means opposite or opposing. So we're going to make the opposing statements, is the point. So our first statement in the diagram, or in the book, so the order in which we do things is we start off with a statement of what is to be proved. The second step then is to write a contra statement. Now, you've done some of this when you were doing statistics, when you were doing distributions or normal distribution. A lot of the situations you solve by trying to find the probability of the opposite thing, and that's more or less what we're doing. But we need to give the contra statement isn't just reverse every single part of a statement. We need to reverse the meaning of the statement. So number 3 is if we get an impossible situation, it means, write a contra statement which is effectively a hypothesis, a theory, a statement that we believe to be true. Then we can actually then turn around and say we have rejected the hypothesis or the statement, and hence we are now proving that statement. The hard part is this writing the contra statement. That's the critical statement, is going that way. It's being able to write the right things if where possible. So let's start with an example. They want to prove that if A, B, the product of A, B is irrational, there's no simple symbol for irrational, then at least A or B was irrational. Let's think about what they were saying in that first. So the first thing they're saying is, if I've got an irrational number, good irrational numbers are square roots of primes. So we're trying to say if something like 3 times the square root of 2 is irrational, which it is, then either A is irrational or B is irrational. And in this case we found it was B was irrational. Okay. It doesn't necessarily mean that, and this is where the caution comes, some people would turn around and say that if A is irrational and B is irrational, then we can prove that it's wrong by proving that is rational. It's not always true, but it can be true. So we need to carefully choose our contra statement. So our contra statement in this case is if A and B is irrational, so the first part we're going to take as true, irrational. We can, the reverse of at least A or B is irrational is to actually turn around and say neither A or B is irrational. That's actually the opposite statement. So what we've now got to try and do is we are trying to therefore show that A and B can be rational. So we now need to write some expressions for our two values. And this is where that list above was useful. Did we have it before? Yeah. So we've got rational P and Q. So let's say let A equal P over Q, let B equal R over S. If we do A times B, it's the same as P over Q times R over S, which is PR over QS. PR we know is two natural numbers, they're both integer. Integer times an integer can be assumed to be an integer. So PR belongs to our natural numbers, or integers. Actually, it should say integers in this case. Let's say integers. And QS also belong to integers. As they are both integers, this can be written as a rational. It's a rational answer. It can be written as a fraction. Okay, sorry if there's a little bit of background noise. Volume down, please. Because my son's just come in the room and he's listening to something on the computer. Right, second part of this, so finishing this off, We've now shown that AB must be rational. Because that's rational, we've actually found the contra argument. So this is actually shown to be false. Saying basically A and B cannot be rational. And because of the way we've put this situation together, it leads to the statement reversing this first part. So we've now shown, hence QED, AB belongs to rational numbers, then at least A or B is rational. At least A or B is irrational. So that's the sort of things that we get asked to prove. A couple of other ones that might come along, or they talk about